universe was born 14 billion years ago in the Big Bang, and it has been expanding steadily ever since. But there is a strange mechanism driving this growth. Between the galaxies, brand new, completely empty space is continually bubbling into existence out of absolutely nothing. This creates a massive cosmic tug-of-war. On one side, we have matter. Galaxies, gas clouds, and dark matter all possess gravity, and gravity pulls everything in the cosmos tightly together. This model visualizes the battle. We see gravity acting as an inward pulling force, fighting against an invisible, opposing, outward pushing field known as dark energy. Dark energy is essentially the intrinsic energy of empty space, acting like an anti-gravity that aggressively pushes reality apart. The universe is eventually going to die, and exactly how it meets its end depends entirely on which of these two physical forces overpowers the other. Let's look at the first scenario. If the intrinsic strength of dark energy decreases over time, gravity gets the upper hand. The relentless expansion of the universe grinds to a halt. Then, an agonizingly slow contraction begins. Over billions of years, isolated galaxies and massive clusters reverse course and rush toward each other. This animated diagram shows what happens to the ambient energy in that collapsing environment. As the spatial grid shrinking down forces everything together, the trapped radiation from every dead star and quasar that ever existed multiplies in density. The empty void between stars heats up violently. This creates a concentrated cosmic oven. Before any planets or stars actually collide with one another, the surrounding space becomes so incredibly hot that they literally boil from the outside in. In the final moments of the collapse, all the remaining plasma merges. The entire cosmos compresses into a single singularity of infinite density and zero physical space. If matter wins the war, our universe is completely unmade in a claustrophobic, fiery reset. The second scenario looks at the exact opposite extreme. What happens if dark energy grows exponentially stronger, completely overwhelming gravity? The unraveling starts on a massive scale. Dark energy generates new empty space so aggressively that the distances between galaxies inflate, and eventually, individual star systems drift away from each other into darkness. This footage illustrates the sudden escalation as dark energy overcomes local gravity. It begins tearing through the physical structure of matter itself, shredding solid planetary bodies into scattered debris. The final escalation happens in a fraction of a second. The expansion becomes so utterly furious that atomic nuclei are separated. Space-time itself is obliterated to its core. An enraged, increasing dark energy rips the universe apart from the macrogalactic scale down to the quantum scale in a terrifyingly swift tear. The third model assumes dark energy remains entirely constant. This leads to an excruciatingly slow war of attrition. In the short term, gravity manages to win a few local skirmishes. Nearby groups of galaxies successfully overcome the outward push of expansion, merging into heavily populated, massive supergalaxies. But as we see in this macro-scale model, dark energy secures the long-term victory. While those local dots merge into bright nodes, the negative empty space between them expands exponentially. Dark energy pushes them further and further apart until they become completely invisible to one another. Trillions of years pass inside those isolated pockets. Available gas reserves deplete, preventing any new star formation. The existing stars burn through their fuel, eventually cooling and leaving the supergalaxies as dark fields filled only with stellar corpses. Fast forward googles of years to the absolute final state. All remaining black holes evaporate. Every big and small structure dissolves into single, lonely particles, drifting endlessly through an infinite expanse of empty space. A constant dark energy guarantees the heat death, a completely featureless, eternally expanding void where nothing can ever happen again. Based on current observational data and mathematical models, physicists believe the universe is currently locked into this specific trajectory, the slow, eventual stalemate of heat death. An eternally cold, dead universe might sound bleak, but it comes with a staggering upside. This specific path to the apocalypse takes the absolute longest amount of time to complete. This logarithmic timeline chart compares the cosmic clocks. We see the abrupt, catastrophic durations of the Big Rip and the Big Crunch on the left, dwarfed by the heat death era stretching practically to infinity. It grants us trillions of years, time enough for consciousness to expand, jump between stars, and exist long before the lights finally go out. Understanding the universe's ultimate demise isn't a reason to despair. It is the greatest argument to explore, appreciate, and make the absolute most of the vast, fragile window we get to live in right now.